Hi guys, we're going to be talking about flash flooding today. So I've got a couple things to do out of the module that you'll be taking a quiz on, and then I've got some other things to add for this lecture. So the first thing, let's go ahead and share the screen. Your severe weather videos under miscellaneous. Remember, this is under the worksheets tab folder. There is something called floodplains by design, and I want you to open this, and I want you to take notes on this part. This is a wonderful explanation of how we start planning floodplains, okay? So there's information in here that you definitely want to get into. So go ahead and look at this video, take notes on that video, and then come back and start this one up again, okay? Go to the flash flood processes module, and this is a flash flood. What is a flash flood? So hopefully I can get you this. Couple things in here is that we're defining a flash flood, and the key part of this is to say that it's within 6 hours, maybe even less, of the causative event. So whatever it is that's causing the flash flood, it's going to happen fast. So most of the time when we're talking about flash flooding in your life, it's going to be intense rainfall. But if you have a dam failure of a dam. Now remember, what's a dam? And you should know this. A dam blocks the flow of a river. So you can build up water behind a river. This is stuff that's in the watersheds, is that we have a reservoir behind the river or behind the dam, and then they let water go down. If you look up, and you should probably try to Google this, the Johnstown flood. This is one of the worst disasters in American history when a dam collapsed, killed I think over 1,500 people. Now a levee, and you should know what a levee is a part of land that you form as the river is parallel to those levees. So it keeps the water from flowing out of the banks. That's what a levee is. And if those things have failure, water can flood an area very rapidly. This is what happened with Katrina in New Orleans. So anything else? Other things that could happen are ice jams or even beaver dams, where ice jams can get caught and the water starts overflowing the bank and you get a flash flood. But obviously, most of the time we're going to be talking about flooding as a result of heavy rainfall. Now remember, a flash flood is different than urban and small streets advisory when there's heavy rain. A flash flood is actually something that can be life-threatening. Okay, so we're going to be looking at what's the watershed condition. This is something that we'll go through, and I will have I already have the answers to the watershed worksheet. Make sure you've gone through that though. What's the condition of that? So we're going to use the term antecedent. Okay, so antecedent. What I'd like you to do, oops, let's try spelling that right. There we go, antecedent. I want you to take a look at this word. Ante means before. So if we talk about the antebellum period in the United States, that's pre-Civil War. The opposite of ante is post. So we have ante-meridian and post-meridian. You probably know them as AM and PM, meridian being the middle part of the day. So an antecedent condition is what is the condition of the watershed prior to the event that's happening. So we can get flash floods if it's been raining a lot because there's no more area for the water to sink through. The land can't absorb any more water. On the other hand, you also are going to be talking about a drought condition. Maybe the water is impermeable or the surface is impermeable to water, meaning it can't go through that. And I'll give you some of these words in a little while, okay? How much rainfall, maybe there's snow on the ground, there's a lot of water in snow if it melts rapidly. All these things go into the flooding situation. So what we need to understand is how does the watershed work? So I'm going to go ahead and take that out, and here's the ground. If you recall, we always do the ground with little diagrams like this, so we know that up is to the top of the page, right? So there's the ground, and then I'm going to be really simple with this. Just go to a pen here, and I'm going to draw a cloud, okay? And what the cloud does is it rains, okay? So this is going to be a lot simpler than the cross section of the isobaric surfaces. We have rain. Now, at this point, a couple things can happen. Rain will either go into the ground, okay? And that word that means to go into the ground that we talked about is infiltration, without the O. I wish I was a better typer. Infiltration. If it doesn't infiltrate, then what else can it do? And you should probably know this. It then will go this way on the ground, and this is known as runoff. Okay, so we have infiltration and runoff. And the key thing about this is that infiltration is not what's causing the flooding. It's the runoff that causes the flash flood. So we draw the river in here, okay? So we have the water that runs off into a stream, okay? Now, there's also a process going on in here that has water, once it infiltrates, that goes into the stream. This is called interflow, okay? So interflow is the fact that water will eventually kind of go into the river under the surface, okay? That's what's going on. So the rain falls, it either infiltrates or it runs off. Now, the rain, the water will eventually keep going through the ground, further and further down. It kind of creeps through the ground. This defines percolation. Now, eventually, we're going to get to a place down here someplace where there's water underground, okay? And that water is kind of trapped in here because on top of the water, there's a layer of what? What is this that kind of traps the water into here? And the answer is bedrock. So the water kind of gets trapped in here on top of bedrock. So if I'm going to draw this diagram, this is bedrock, which is impermeable. And impermeable means you can't get the water in there. And then this storage of water underground is called an aquifer. So we have the water in an aquifer underground. The bedrock is impermeable and the water doesn't percolate any further down. Okay, so we have rain, runoff, interflow, infiltration, percolation as it goes through the ground. So soil often has water in it, and after a course of time, gravity will pull it down depending on what the soil is made out of. Okay, and the water will then come out of the ground and the soil starts to dry up. Now, what if the antecedent conditions had a lot of rain yesterday, let's say? Well, the ground becomes saturated. So what happens is when it rains again, the water doesn't infiltrate very well. So more and more water has to run off. It's all trying to go into a stream. That's where it's trying to go, which is all going into different watersheds, river basins, goes down. Eventually, it will drain into the ocean. Okay? So that is what we've got here. Okay, back to here. So all these things are kind of going up there. Then when we get to a river flood, we're going to be looking at the hydrograph. But what are the watershed's conditions, the antecedent conditions? How much rainfall will it be? How much snow melt if there's snow? How impermeable is the surface? Okay, so over here, and we've talked about this, there's rainfall and runoff relationship. Infiltration, surface runoff. Okay, now, here's the review questions, pretty simple. Begin within 6 hours. A causative event may be what? Intense rainfall, dam or levee failure, make sure you've got those defined. Storm surge, you can get flash flooding. You can get flooding with a storm surge. This is when the ocean comes on. We're not going to call that a flash flood. But we have rapid water rise associated with river jams. And then flash floods are almost always associated with saturated soil conditions. That is not necessarily true because you can have impermeable surfaces if the surface is droughty, full of drought, right? If it's really dry. Okay, so we go to the end of the page. We can go back to the table of contents. And now we're going to go to hydrologic influences. Hydrologic, we talk about the water cycle, that's the hydrologic cycle. So it says soil influences. Here's what they care about: soil moisture, texture, and profile. Well, here we see standing water on soil. That means the infiltration rate is basically down to zero. It can't absorb any more water. It's going to take time for the water to eventually drain. So if I go outside one morning and I see the soil with standing water, I know that the ground is saturated. So any rainfall is going to start leading into more and more flooding. Okay? So you can kind of take a look at this. And then there's also these particle sizes. So I think a fun thing to do would be soil particle size. Notice I use Google whenever I need to find stuff that's pretty straightforward. So I could look at lots of things in here. I think I'm just going to go to the images because I can find one pretty easily because I know what I'm looking for. What do you think, if I look at this, what do you think will drain faster? Big particles or small ones? Think about putting sand in a jar and putting water into it. Do you see that the water will trickle down to the bottom? But if I had big gravels or marbles, the water will go through bigger spaces and make it down. So if I look at something like this, here's something that talks about sizes. To the left is the smallest size. So the very smallest particle is clay. And you know that you make clay pottery. So you put water in clay and it's going to contain the water. The water is not going to drip through it. So as far as impermeable surface, the more clay-like, the less water that can be able to infiltrate the ground. The next size bigger is silt. So clay and silt are the two smallest. And then we go into sand. Sand's the next one. And you know that when you get coarser sand, it's easier to drain. At a beach, you can contain water for a little bit, but the water will eventually drain through the sand. The next one will be, and I'm going to put something inside here instead of fine gravel. I'm going to call them pebbles. Pebbles are real small rocks. Then we got gravel. And I'm going to go two bigger ones than pebble and gravel. The next one is called cobblestone, C-O-B-B-L-E-S-T-O-N. So if I do cobblestone, have you ever seen cobblestone streets? Where a street might look something like this. This is a cobblestone street. This is bricks. These are sort of bigger stones in here. They're nice big chunks. And then you know what's bigger than cobble? Would be boulder. So small to big, clay, silt, sand, pebbles, gravel, cobble, and boulders. Water doesn't drain through small particle sizes. Water drains through large particle sizes, okay? So go ahead and put that in there. Let's go back to here. And here's an example of that. See, sand is big, water goes through easier, clay is not. So flash flooding, if your soil is a lot of clay, it's easier to do that. Okay, and then we can talk about river basins. I let you go through here. Now, here's what I need you to know, and these are some important diagrams to put into your notes. The size of the river basin and the amount of runoff. Okay, so I'm going to click on this to do an animation. I think I'm going to click on it and do an animation. Yes, I want to do the animation. This is another stupid thing. Okay, so what I'm saying here is that the longer the distance of a stream, the longer it takes to travel. So here's what you need to know about flash floods. Ready? Big time important. Flash floods happen the faster water can travel. So if I have a really big basin size, it takes longer for the water to move and less flash flooding. Smaller basins, better flooding. Okay, so that's kind of what they're talking about here. Now, the other thing that makes water go fast is if I've got more streams. So it's what we call basin river density. The greater the density, the more rivers in a water basin, the more likely the flooding, because water floods moves faster when there's a lot of streams, and that causes flooding. Okay, so what happens if I have an urban watershed? Well, I don't have as many streams perhaps, but I have roads and sewers, and all those areas are letting the water drain rapidly, and they'll fill the rivers quickly, and the waters will rise. So you'll get some flash flooding from some of those river flows. So urban watersheds tend to flood easier. In addition, and this is so important, so huge asterisk, big time important. Why do urban watersheds flood easier? Well, there's more streets, more streams in that higher density water basin or watershed. The second reason is that there's more impermeable surfaces. Remember, we said infiltration is what we want. Runoff is flooding. If we have asphalt parking lots and driveways and houses, that water is not going in the ground, it runs off. So that will cause flooding a lot more. So this graph becomes super important. Now there's two things on this graph that I want you to know. The first one is flow, how quickly, how much flow, how much runoff. Over here it's time. So I want you to look at green, which is rural, and red, which is urban. So urban sort of in the middle. Okay, and what that means is we're going to have more flow, more runoff, and it's going to happen more quickly. More runoff and more quickly in terms of flooding. Rural watersheds will take longer and it will not be as much flow. So what watershed floods the easiest? Urban watersheds. Okay, so keep that in mind, please. Now here's some interesting things. If you remove vegetation, now think about this. I said fast water floods easier. If you have smooth surfaces, it moves fast. If you have a lot of plants and trees and brush, the water slows down. So this is an example of what happens if there's a forest fire. You remove all the vegetation. Now the next time it rains, flooding is more likely, okay, because you're moving that water quickly. Plants, vegetation, slow water down. Okay, I hope that makes sense to you. I want you to go ahead and take a look at these. One other thing, right? The efficiency of runoff. We said fast waters flood easier. So what else makes water flood, a watershed flood quicker? And the answer is the steeper the terrain. Think about it on a mountainside. Water's coming down really fast, and you're going to get unbelievable amounts of flooding very quickly. Flat areas don't flood as rapidly. It rains a lot, you might get a little bit of water coming up, a couple of inches, that's not a big deal. So keep that in mind, that what kind of watersheds flood faster? No vegetation, more impermeable surfaces, higher stream density, and steeper slopes. Because all of those things get that water moving fast, and that's where your flood's going to happen. So read through this. There's some good information in here that should help you. And now we're going to go back to the top of the page and go back to here, and we'll go to flash flood guidance. Now this thing is interesting, and there's some stuff in here that's a little bit harder. You'll have to figure it out for the quiz, but I'll tell you what's important. FFG, flash flood guidance. It says, how much rain do we need in order to provide an environment that will flood? So over here, there's an example of this. And what's really important here, folks, is that you know that flash flood guidance comes in 1, 3, and 6 hour time durations. So how much rain do we need to flood in an hour? How much rain do we need to flood in 3 hours? How much rain do we need to flood in 6 hours? So over here, notice the blue is smaller amounts. I need smaller amounts of rain here and here to flood. Why do you think that is? Well, primary reason, this is where it's really like the Black Hills. Very rugged terrain, fast moving water. Over here in the flat areas of Nebraska, requires more water to flood. This is sandy soils. This is able to let a lot of rainfall before it floods. So the National Weather Service looks at these flash flood guidance, FFG. And the key thing about this, and here's some examples of what they may look like. I'm not going to worry about all of these things. I'm not going to worry about how you do gridded data versus county-wide. I just want you to understand that flash flood guidance is always changing. So imagine that we have flash flood guidance today and it's 2 inches in 3 hours, and that would cause flash flooding. But today we have rain, and it rains about 1.5 inches all day. Not in 3 hours, but all day. Are we expecting flash flooding? Probably not. But do you agree the ground is probably really saturated now? We've had a lot of rainfall. Tomorrow, what do you think the flash flood guidance would be? Well, instead of being 2 inches in 3 hours, may only need 3/4 of an inch in 3 hours. And that kind of setup, if we have multiple days of rain, start leading to flash floods. Okay? So obviously county average doesn't give you the important thing of gridded. That's kind of what they're talking about. Here they're talking about thresh R. You might need to use this for the quiz, but I'm not going to ask you this in a test. Okay? We're talking about the hydrographs. We did mention that before. Runoff curves. Again, this is stuff you might need for the quizzes. You can go look in here, find the information you need, but I'm going to kind of skim over this because I don't want this to be the super important things that you take out of here. So don't go crazy looking at all this stuff other than to answer the questions for the Med Ed quiz. Okay? So here's some ideas of rainfall accumulations. Well, we have something known as QPE. I think I've mentioned this. QPE stands for Quantitative Precipitation Estimate. Okay? Radar, which tells us how much rain we've been getting, can give you QPE. So I want you to see something here. I'm going to go over here to our homepage, and I'm going to go to a special text page. I don't think this is not linked on this, but it is weatheredu.edu/text/expert. I think we've talked about this before. So there's the URL for that. And I'm going to go to hydrologic. Again, water. And right now we're looking at all sorts of products that come from the Weather Prediction Center, excessive rainfall outlooks, QPF, which we'll talk about, and here's multi-radar, multi-sensor, QPE. And I'm just going to go over here, I'm going to say, well, according to radar, how much rain have we gotten, in this case, over the last 72 hours? If I were to loop this, I see the development over the last several days of where there's been a lot of rainfall, okay? So that's what QPE is, how much rain is falling. Obviously down here, and if I look at 48 hours, I've had over 10 inches of rain in parts of southeast Texas. So I'm thinking this is much more likely to flood, okay, because I'm getting a lot of precipitation. And I can use this on smaller times. So here's 1, 3, and 6. So here is the latest 6-hour one. This can take a little while to load, but this is a 6-hour QPE to see how much rain have we gotten. Now, if I know that we've gotten 4 inches of rain, let's go over here. If I've gotten, let's say, 4 inches of rain in 6 hours, but I know that the FFG for 6 hours is 3 inches, what do I expect? I expect the ground's not able to get as much water to infiltrate as it's falling onto the ground. It will run off and cause flooding. There should be a flash flood warning. Why? Because this is what's happening. Well, how do I know if it's going to happen? Well, instead of QPE, I'm going to look at this thing called QPF. QPE is quantitative, quantity, precipitation estimate of what has happened. We use radar. QPF, it's what's quantitative precipitation forecast. What do we expect? This is coming from models. This one is WPC, the Weather Prediction Center. So where are we expecting there to be a pretty good amount of rain over the next 4 to 5 days? And the answer is up here in Montana. Are we going to get some rain here? Yes. Down through the mid-Appalachians? Yes. So there could be flash floods going on in this region. Now I go to the hydrologic page and I see a couple of flood warnings that's associated with river, but I'm seeing no flash flood watches. Right? I'm not anticipating it yet. just to show you how things like this go together, on this day, I happen to know something about the weather that we're supposed to get tomorrow, which is going to be thunderstorms. And I'm going to go to the Chicago area, and I'm going to go to the hazardous weather outlook, right? We know that's where we should go. And so what is the hazardous weather outlook? Not too much today, but tomorrow we have elevated severe thunderstorm risk. We have a day 2 convective outlook. We have a flood risk and an excessive heat risk. The dew points tomorrow are going to be really high. It's going to be hot. Temperatures up near 90. That means our feels like temperature, or the temperature relative humidity index, is going to be high tomorrow. So there's a possibility of heat tomorrow. We are looking at the possibility of severe thunderstorms, especially in terms of high winds. We also have the possibility of flooding because there's going to be a lot of rain. So if I were to go to something, and these are numerical models, and I think I've shown you some of these before, I might want to look at, well, how much rain am I expecting tomorrow? And I would go in here where it says precipitation, and it says precipitation, or 6-hour, or total precipitation accumulation. Do you see that this is really QPF? This is what we're forecasting to be. And look at what we're getting across parts of northern Illinois into southern Wisconsin in the next, about 48 hours. We're looking anywhere from 1 to almost 1.5 to almost 2 inches of rain across parts of northern Illinois. That's the potential for flooding. Okay? In terms of 6 hours, I'm going to see a pretty heavy amount of rainfall tomorrow evening across the Wisconsin-northern Illinois border, and we should get some pretty heavy rains. And so we're going to look out for flash floods. Is there a watch? Not yet. We'll see tomorrow. But let's say that it's going to be a lot of rain. The National Weather Service in Chicago will issue a watch, flash flood watch. Then they'll monitor. And if the rain's bad and it starts exceeding flash flood guidance, a flash flood warning will be issued. If it's not, they may have some urban and small streams flood advisory. That's the only advisory level flooding. Or they may just say it's a flash flood watch. We'll see. And we'll see how much rain actually falls. And then we'll look at the radar and say, all right, it's time to put a flood warning out. And that's how it works. So when you go to this section, this is rainfall accumulation. This is QPE. And we know something about this is what it looks like when there's flood. So what is flash flood guidance? Here's the deal. So important. It is rainfall depth over a time duration. How much rain over time duration? Okay, that's kind of important. The next one is, for this question here, what does it account for in flash flood guidance? This is a little bit harder, but soil moisture, it does account for. Duration of the rainfall, it does not deal with the texture or land use. I'm not going to test you on that, so you don't need to worry about that too much, okay? Top of the page, we go back to this version, and we get a little summary. And in this summary, I think this is something that you should probably have. You do not need to worry about a lot of this stuff. So I wouldn't worry about this too much other than maybe the first bullet point. Okay? Now, that is a little bit about flash flooding. What is the National Weather Service motto about flash flooding? Turn around, don't drown. Okay? So here's the big thing that you're going to have to do. And I had some of you guys did unbelievably great jobs at discussing the tornado videos. On this video here, there is flood videos. I'm telling you, some of them are disturbing. The tour bus and the school bus and India are a little bit scary. The school bus is not bad. The tour bus and India, people are dying. But I want you to see that because it's important that you get into your brain. When I say flash flood, sometimes it's really amazingly fast. The Vegas flood, it's a fun video. You know, go get yourself something to drink, something to snack on, watch these videos. Big Thompson River is a mountain. That's a very famous river. There's something you can look in there. It's incredible amount of water. And then this Chris Novi video. he teaches people, turn around, don't drown. So about a minute and a half in, you'll see something pretty amazing. So take a look at this. He did survive, but he was underwater for about 30 seconds, came this close to drowning. You'll see in the video he passes a cop. It was that cop who saved him when he crashed his car in 10 feet of water. He basically turned, he was going to turn around not to drown, thought it was a driveway, it was a river, and he went right into 10 feet of water. So I want you to watch them and just write up your opinions about 2 of them, okay? But I want you to watch all of them. It'll take you about 15 minutes, and it's really interesting. It's just amazing. The 2 Wamba, that's funny. I think you'll enjoy watching that one, at least part of it, okay? So you've got a lot of videos to watch on this part of the module. You've got some questions to answer. There's one last thing that I want to bring in here, and I'm going to go back to our models. And this is something that I think is really important. So I'm going to use this model, and I'm going to go to North America. We have something known, here's precipitation, that's QPF, quantitative precipitation forecast. But the other one is called precipitable water. Now remember, we said that in the atmosphere there's water, vapor, and then we make that air go up, it condenses into the cloud at the LCL, it eventually rains out. We'll talk about later in the class how do we get rain to form. But eventually it rains, okay? Well, how much water can I get out of the atmosphere? Well, that's what precipitable water does. It says, all right, take the entire atmosphere. How much water can I get and how much rain will fall? If I could take it all out, how much? So precipitable water is measured in inches. So what we're saying is here's anything in yellow can get 2 inches of liquid water out of the atmosphere. Think about that. How much vapor is in the atmosphere? And if it all rained out, 2 inches of water. That's a lot, okay? 1.6 is the purple, and then the brown is drier air. So this is all precipitable water. Now, if you want to be cool, we call them PWATS, capital P-W-A-T-S, PWATS, precipitable waters. I want you to watch this for a second, okay? Here's precipitable water. Look at our area tomorrow. Do you see how we increase precipitable water? Anytime we see that going on, thunderstorms are much more likely. When we see a surge in PWATS, that's going to be important. We're going to be getting into this on our next unit, which is fire weather. Okay? So PWATS are in here, and we see the PWATS, and then we kind of go forward, and we're staying very humid and moist for a couple of days. Look at how dry it is in the southwest. Okay, so the dry continental tropical air and the maritime tropical air that's going all the way up to Hudson Bay. Lots of precipitable water. Okay, and you can see how it just kind of moves all over. Now look at this in Arizona. All of a sudden, in 2 weeks, we get this surge of PWATS. And I'll come back to this. That's in the fire weather one, is going to be the pre-monsoonal moisture surge. So this is kind of cool, but this is, the desert is going to start getting rainy. And therefore there's going to be thunderstorms. And we'll talk about this in terms of fire. But we use PWATS to really get an idea of what's going on. Look at this as we go into the future. There's a big region of high PWAT values coming into Texas. So this is going to be an area, in the next few weeks, we're going to see a lot of rain. A lot of times I'll see like this. Look over here. What do you think this is? You can actually see it spin. When we start seeing those incredibly high PWATS, that's probably a tropical storm or a hurricane. So kind of a cool thing. We see where it dries out. We see where it's going to be humid. And we see some really high areas. And what that's going to mean is over the course of time, we're going to see a lot of precipitation coming our way over the next couple of weeks. In fact, I can go in here to the US and I can say, well, how much QPF, quantitative precipitation forecast, I'll do total. And if I look over the next, this is basically 2 weeks. I'm looking at some areas, man, there must be some serious thunderstorms across southern Canada with 7 inches over the next 2 weeks. Here across Illinois, we're 1 to 2 inches. Over here, we're looking at 5 inches of rainfall in East Texas. So we have the potential for a lot of rain. Southern California, it's that time of the year where it's dry. But even into Arizona, now we're looking at 1.22 inches of of QPF, not PWES, but actually forecast water. So it's going to get rainy, and that's what we're going to get into the monsoon, and that's where we're going to go as we go into fire weather. Okay, so good luck with this one. This is a pretty juicy a module or a lecture of a lot of information. Put it together nicely and neatly. Some of you have been doing great from the beginning. Others of you have done amazing improvements. Keep it up. Make it detailed. Give yourself as much as you can. Study it while you're writing it so that when you take the test on this, you'll be in much better shape. Okay, guys, we'll see you later.